Okay, start. Now the point is what I have to tell you is that the required centripetal force, centripetal force, the required centripetal force for the circular motion for the circular motion is provided by the is provided by the magnetic force. Just now I told you the centripetal force, the velocity is the perpendicular component of velocity. So we write V perpendicular square mv square by r, assuming the radius of the circular path is r, is nothing but bqv. That is, q is the charge of the particle, v into v. So this is the expression which you have to remember. Here v is the perpendicular component of velocity. V perpendicular is perpendicular component of velocity, and v parallel, there are two things, that is parallel component of velocity. Okay, so if you are asked to find the velocity, what would be the magnitude of the velocity? If they ask you, that is square root of v perpendicular square plus v parallel square. That's how you get the velocity. So now let's cancel this part, and now you will get an expression that, so the you need to find the expression for the radius. Radius is m v perpendicular divided by bq. This is the most important expression. This is the radius of the circular path traced by the charged particle in magnetic field Of course, what would be m? M is mass of the particle, mass of the charged particle. M is the mass of the charged particle. And you know what is B? B is the magnetic field strength. So the magnetic field, that's it. We'll write magnetic field or magnetic field strength. And then Q is the charge of the particle. Q is charge of particle. M is the mass of the particle. We have written this. Anything else? V perpendicular. We have given everything. We have given. So that is R. R is this is the expression for the radius of the circular path traced by the charged particle when the magnetic field is applied. So once finished, please let me know. Once finished, please let me know.
Done, sir.
Okay, good. Now, now we got the expression R is equal to M into V perpendicular divided by BQ, right? But M into V perpendicular is the momentum divided by BQ, like this, where P is the momentum. NTUM momentum, that is M into V perpendicular. Of course, mass into product of mass and velocity is called momentum. Okay. Now, what are the things we will get? The radius of the charged particle is proportional to the momentum, and radius of the charged particle is inversely proportional to the magnetic field, and the radius of the charged particle is inversely proportional to the charge on the particle. These are the three very important expressions. Very important. So if I write R1 by R2, I will get P1 by P2. Okay, first one. Radius of the one particle to radius of the next particle is B2 by B1 if they are subjected to different magnetic fields. Okay, how the radii would be, keeping the momentum other thing quantities constant. Keeping all other things constant, R1 by R2 is equal to Q2 by Q1. Higher, larger the charge, smaller the radius it would be. So that's how you can get the expressions. So we know the kinetic energy K is equal to P square by 2m. And we can write P is equal to square root of 2mk. So when I substitute that here, I get a different expression, square root of 2mk, where k is the kinetic energy divided by bq. We can write this. Okay. The next one is the time period. Time period. The time period is given by 2 pi r. 2 pi r, it's the circle, it follows this much length it has to cover, divided by v. That is called time period. So you can very well write the expression for r. So 2 pi by v into mv by bq. You can write this. So you can cancel this v and v, right? So the time period is given by 2 pi m divided by bq. So 2 pi m divided by bq. That's how you can write. So once finished, please let me know.
Done, sir.
Yeah. Now there are some few more parameters to see. The angular frequency omega is given by 2 pi by t. So when you substitute the expression for t, how it will change? Let us see. 2 pi by the t is 2 pi m divided by bq. divided by BQ. 2 pi gets cancelled. So BQ divided by M. This is what I will get. This omega is sometimes called cyclotron frequency. Cyclotron frequency. It's called cyclotron frequency. So this is the principle used in a device called cyclotron. Cyclotron is actually a particle accelerators. These are called particle accelerators. We can accelerate the charged particle. So that is used for several experiments. Of course, the velocity of the charged particle is given by dq divided by 2 pi m. So this is how the velocity expression can be, and omega, and that's omega is called cyclotron frequency. And we have another parameter for a helical path. For a helical path, the distance moved, the distance moved along the magnetic field, along the magnetic field in one rotation, in one rotation is called pitch. It's called pitch. So pitch is given by V parallel times time period. So that's how pitch is done. So you get V parallel times time period. That's how we'll find it. So the time period is we got the expression. What was the expression for the time period? So from here itself we can get, so T is equal to 2 pi by omega is like 2 pi m divided by BQ. So that's how time period, and V parallel times the time period is 2 pi m divided by BQ. So if the parallel component of velocity is given, you can find it 2 pi m V parallel divided by BQ. This is called pitch. So this is sufficient today. So tomorrow we will see motion of a charged particle in uniform electric field. That is another thing, and something called Lorentz force. After that, cyclotron. Cyclotron, yeah. After cyclotron, we have some few problems. Yeah, I told you it takes about some 2-3 classes. Then and few other things I have to discuss. With that, the chapter will be completed. 2-3 classes on around next week. It may take. Next week I can complete with all the classes, all the chapter. This chapter I can complete by next week. So next week again. Tomorrow we have another class. Don't forget. Next week again Wednesday we'll meet like this. No problem. If possible, some other time also we can meet, so that we can have a longer session also next week. Definitely.
Sir,
So
tomorrow same time, no, sir?
Same time, 7:30 we'll meet. No problem.
Okay, sir.
Okay, right. Okay, yeah. Thank you all. So I'll upload this whatever we have done today. So please watch this if you have any kind of doubts. Okay. Thank you all.
Sir, just a minute, sir.
Yes, ma.
Sir, I have sent you mass B questions, sir, from straight lines.
We'll discuss some separately. We'll discuss. No problem.
Actually, oh, okay, sir. Okay, sir.
Can we do it tomorrow?
Okay,
or
sir.
sometime later I will make a video out of it and I will send you. Okay.
Sir, that's only 5 questions, sir. Could you
We'll do it.
send by this
Don't
night?
worry. We'll do it. We'll do it. No problem.
Okay, sir.
No problem. Right.
Thank you. Thank you, sir.
Okay, all right. Bye.